Welcome to section 4.5, graphs of cosine function. So we'll continue with our graphing of the trig functions. Cosine function is going to be very similar to the sine function because they hold a lot of, or all of the same values, just in different locations. So let's kind of go through our t-chart again and figure out what that cosine of x is going to look like. So at x equals 0, that's the ordered paired 1, 0. Remember, cosine in terms of our unit circle is equal to the x value. So in this case, x would be 1. So cosine of 0 is 1. We'll do pi over 4. These are going to be all our square roots of 2. So that'll be square root of 2 over 2. Pi over 2, that would be at 0, 1 in terms of the ordered pair. So cosine of pi over 2 is 0. 3 pi over 4 cosine. Now remember, x is negative on this side. So you'll now get negative square root of 2 over 2, which remember, these are approximately 0.7. At pi, you're at negative 1 comma 0, so cosine would be negative 1. 5 pi over 4, you're still on the negative side of x, so that's negative square root of 2 over 2. 3 pi over 2 at 0, 1, 0, negative 1 will now be cosine of 3 pi over 2 is 0. 7 pi over 4, you're now back on the positive side of x, so that's square root of 2 over 2. And then 2 pi back at 0, so cosine would be 1. So now we'll go ahead and graph each of these, so we'll mark it off in those fourth intervals. So this will be, pi over 4. We got pi over 2, 3 pi over 4, pi, and then we'll do the bottom half as well, all the way to 2 pi. And we can kind of look at the other side in terms of negative. So what's going on here? Well, let's go ahead and mark, we'll say this is 1/2, this is 1, in terms of the y-axis. Same thing here. So really the same setup as last time when we did the sine function. So let's plot the points that we have. So at 0, it is now 1. At pi over 4, it is 0.7. At pi over 2, it's 0. 3 pi over 4, it goes down to negative 0.7. At pi, you're at negative 1. Then we start to work our way back up, 0.7, 0, or I guess it'd be negative 0.7, 0, back to positive 0.7, and then at 2 pi, we're back at 1. This represents 1 period of the cosine function. And as I said, we can go back the other way as well and do negative pi over 4. That just means we're going in this direction, so it'd be the same thing as 7 pi over 4. So it's a positive 0.7. Then you're back at negative pi over 2, which would be at 0. And when you get to negative pi, you'll be back at, negative pi, you'll be back at negative 1 there. So this graph continues just like the rest of them. And that's what your cosine graph looks like. Very similar, if you just look at them very quickly, it's very similar to your sine curve. You can actually just see the graph is shifted over for those new values. So we'll go ahead and write some of the same things down in terms of the sine function that the cosine function has. Your domain is still all reals. Your range is still from negative 1 to 1. That has not changed, so you can still see the range is still from negative 1 to 1. The period still represents 2 pi. So it's still it's starting here and ending at 2 pi, and then it starts to repeat. So that's your period, which is 2 pi. Your y-intercept is now at 0, 1. And then your zeros, wrong direction, your zeros occur in a couple different places. We have negative pi over 2 right here, pi over 2, and 3 pi over 2. And it continues as we talked about in the last one. So negative pi over 2, 0. We also have pi over 2, 0. And then 3 pi over 2, 0. But these also continue in both directions at those intervals. And then even function. Cosine is an even function. We talked about even and odd functions in our original chapter of trig functions. So what that means is that if we have cosine of negative x, it is equal to cosine of x. So whether you plug in x or negative x, you still get the same output, which means it's symmetric respect to the y-axis. So if you're reflecting over the y-axis, your y value stays the same even though your x value is becoming the opposite. And you can see on your graph, like this point right here, so even though this is pi over 4, it's still at 0.75, and negative pi over 4 is still at 0.75. So it doesn't change, and that's what the even function represents. Same thing as last time with the sine function. You got 5 key points, your intercepts, your max, and your min points. Your period is still 2 pi. Your beginning now, so your beginning is no longer an x-intercept. Your beginning is a maximum, and then now at the quarter marks are where your intercepts are, and the middle, or the beginning, the middle, and the end is where you will have your max and min points as you go through there. So when you're starting your cosine graph, you're going to be wanting to start at the maximum point, where when we did sine, we started in the middle of the graph and went to our maximum point. So pay attention to the differences between where you start with each of these functions. Characteristics, really very similar to what we just did last time. The amplitude is the absolute value of A. The period is still 2b, or 2 pi divided by b. Your interval is still the period divided by 4. You're going to break that period up into 4 equal parts, which is what your interval represents. And then now your intercepts are at the first quarter mark and the third quarter mark, and then the max is at the beginning, which we talked about, and the end and the min will be at the middle of the period. Okay, but once you kind of get that shape down, you'll kind of just go through and you'll recognize where those values occur. And so once again, you'll start at your max. This is what the parent function looks like. Starts at the max, middle, min, middle, back to the max. And that represents one period of the cosine graph. Now that really represents the ends of the notes. If you feel like you have this, I got a couple examples just like I did last time, but really it's very similar to the sine graph. It's just the fact that we will now be starting in a different location. So if you feel comfortable enough, then you don't necessarily have to watch all these examples. If you kind of want to see how it works, I have about, I think, 4 examples here. So first one, y equals 2 cosine x plus 1. We're going to go through and kind of identify everything just like we did before. The amplitude is 2. The period is 2 pi divided by, that b value is 1, so the period doesn't change from the parent function. And then the intervals you break up into 4s, so that would be pi over 2. Your vertical translation, this will be shifted up 1 unit. There's the d value. The 1 is the b, and the a represents 2. And so we have no negative on the function, so there is no reflection. Once again, domain we know is all real numbers. So we'll start by breaking up the x-axis into our intervals being pi over 2, 2 pi over 2, which would be pi, 3 pi over 2, and then back to 4 pi over 2, which would be 2 pi. And so I'll also go in the other direction, and so that would be negative 2 pi, or we can go in the positive direction again and go all the way out to 4 pi. This one has an amplitude of 2 with the shift, so we'll go with the y-axis. Each unit will represent, or each box will represent 1 unit. And now that we kind of have everything set up, we'll start marking those things. Now it does get shifted up 1 unit, so we got to remember, and kind of the way that I do this to help me out is to draw on this dotted line just to indicate, okay, we're getting shifted up 1 unit. So now, where this was my middle of the graph, now the middle of the graph is right here. So up 1 unit, this represents the middle. Okay? So now cosine starts at the maximum. Well, the maximum with an amplitude of 2, that's your vertical stretch, would be at 3. All right, so that's that vertical stretch. From there, we go to the middle, back to the min, which would be at negative 1, sorry about that. So max, middle, min, 3 pi over 2, we're back to the middle, and then 2 pi, we're back to the max. So I've hit those 5 points. I'm going to continue on to kind of get a better feel for the graph. So we'll be back at the middle, the min, the middle, the max. And so now this kind of gives us a nice smooth curve with 2 periods, so you can kind of see that better shape. And I might as well go ahead and do the negative side as well, so you can kind of get the full effect here. So there we go. So I actually end up graphing 3 periods, but kind of gives you a nice idea of what it's going to look like here. The range is from your max to your min, which would have been from 3 to negative 1. So your range, start with the smallest number, negative 1 to 3. So all values in between there, including those. So there you go. So like I said, very similar to the sine function, just really starting at a different location. All right, example 2, we got negative 2 cosine of pi over 2x. The amplitude is the absolute value of a, which is negative 2, so the absolute value of negative 2 is 2. The period is 2 pi divided by pi over 2, but since it's divided by a fraction, I'm going to multiply by the reciprocal instead. And so the pi's cancel, and it just gives you 4. Once again, that represents 4 radians still, and then the interval is the period divided by 4, which is 1. We have no vertical translation. Nothing is being added to this. And we do have a reflection over the x-axis because the negative in front of the function, in this case in front of the 2 as well. So we are reflecting, and we have an amplitude of 2, domain, once again, all real numbers. And then I'll start marking off my x-axis. The period is 4. Therefore, your intervals are 1s, so 1, 2, 3, 4. and then I'll go the other way, -1, -2, -3, -4. The y-axis I'm going to label by going up by 1s. And I think we're ready to go here. There is no shift up or down, so I don't need to change that. I just need to start at my maximum value. Now, remember, normally we start at your max, and it goes like this. But because this one's a reflection, you will reflect across the x-axis. So instead of starting at your max, we will now start at your min. Those 2 points stay the same, and then your min becomes your max. So it'll flip like that. Okay? So instead of starting at my max of 2, because it's a reflection, I will start at my min of -2. And then I'll just work backwards. If I'm at my min, my next point is the middle, back to the max, to the middle, back to the min. Same thing on the other side. I'm at my min, so I'll be at the middle, the max, the middle, back to the min. And so there's your nice, smooth cosine graph. And your range on this one, because we did not shift, is just from -2 to 2. It has to do with your amplitude there, getting that stretch, that vertical stretch of 2. All right, same thing as last time with the sine graph. Describe the relationships between the graphs of f and g. And so what we're looking for is we're going to look for the amplitudes, the periods, and the translations. That's what we're trying to compare between the two of these. So let's just go ahead and write down what we know in terms of g. The a value is -1/2. So that's going to give us the reflection and the amplitude that we'll talk about. The b value is 2, which will help with the period. And the d value is 1. And once again, we don't have any horizontal shifting yet. So c is equal to 0. So let's go ahead and compare and write down the relationship between each of these. All right, let's start with the amplitude. The amplitude is 1/2. So therefore, g of x amplitude is half of f of x. Okay, we also know because of the negative that it is a reflection over the x-axis. So g of x is a reflection over the x-axis. Okay, and then the b, remember the b is going to help us with the period. So the period is 2 pi divided by b, which is pi. So the original is 2 pi, so that means this one is half, the period is half of what it is for the original function f of x. And then the last one with d, the 1 represents the vertical shift, so it shifted 1 unit up from the function f of x. So that describes all the different things that the question asks, the amplitudes, the periods, and the translations from the parent function f of x to the new function g of x. All right, and one more example of graphing. So our amplitude is 5/4. The period is 2 pi divided by 1/2, or multiplied by the reciprocal. So the period is 4 pi, so twice what it originally was. And then if you divide that into fourths, you find that your interval is pi. Once again, we have no vertical translation on this one, and no reflection as well. Domain we know is all real numbers, and then we'll go ahead and mark off our graph, and then graph according to. Since our amplitude is 5/4, I'm going to make sure my y-axis goes up by 4 so I can get a nice accurate graph. I think I'll be able to do that. All right, I have my graph all marked off. There is no shift up or down. So my amplitude is 5/4. Typically I start at my max. There is no reflection, so I will start at my max at 5/4 all the way up here. And since I'm at my max, my next interval will be the middle. The next interval will be the min, back to the middle, back to the max. I'm going to continue on for one more period to the middle, to the min, to the middle, to the max. So that will give us 2 periods. It looks like it's stretched out a little bit more than it is, and that's just because when I made my y-axis, I spaced it out a little bit more there. And so now you can see your range. Since we didn't do any shifting, it's going to be that amplitude from -5/4 to +5/4. And so as we move forward here, that's really the last example. Take a look at the sine and cosine function. Just look at the differences in terms of where the sine function starts, where it starts in the middle, and the cosine function starts at the max. And when I say starts, I'm talking about in terms of that, basically that y-axis in terms of what we're looking for. And then you can kind of go from there where your max and mins are located based on your amplitudes.